I think recordings are in the progress. Screen sharing. So, yeah, I have a question here in the chat. If I draw the dice games class diagram, how should I represent the things of the program.java? So we have this class actually also. Well, you can add it as a regular class. It has a static function operation called main. Inside of this, we have some objects that are created and used. So we have some kind of dependencies from the program class. However, if this class is really just about starting the application, you could just leave it out, because often it's quite platform specific exactly how this is done. So depending on your level of detail in the class diagram, if you're really making it specific towards one type of platform, you could of course include it. Generally speaking, I prefer making design models that stay on the object-oriented design level, so to speak, so they are not geared towards a special platform or a special language or something like that. But it is a little bit up to you how detailed you should actually be, and the needs of the project. Maybe you have really programmers that are really new, and you don't want to leave too much decisions to them. So then you need to make your blueprints more detailed. On the other side, maybe you have really experienced programmers in your team, so then you can probably defer some decisions to them that they actually take when they implement stuff. So, but speaking about that, maybe you remember the dice game, and the last thing we did was actually to implement a small observer pattern to notify that the dice was rolled, and we could then pause the game a little bit, but notify the subscribers that the dice was rolled and the value. So we could get a printout in the user interface, even though we are actually inside the play operation. So maybe we should just test run this and see so that everything works. No, we need to have this one active to run. So we could play, get a small pause, and the other dice there. One interesting thing about this is that actually the user interface does not need to know how many dices are in the game. So if we would like to add another dice, the one good thing is that the only thing that we need to actually do is, well, make a new dice here inside the dice game and create it. And of course we need to roll it also, so we should add a sleep there maybe. And maybe we have a more interesting type of rule then. So we need to get the value from the third dice also. And maybe the result should be like a 9 instead. So as you noticed, I did not change anything but the dice game class. And hopefully everything should work, even though that is early in the morning. No. So that is a actually really cool effect, I think. In many cases, maybe you cannot get this. If you have a more advanced user interface, for example, you maybe have some elements or stuff so that you are actually dependent on how many dice are in the game for the user interface to work correctly. But anyway, this is an example that how we by using the observer pattern we could actually get rid of the if you remember, we had these get dice value 1, get dice value 2 operations in the dice game. Those are gone now. I just removed them. They weren't used anymore. And we can use the observer pattern instead to just notify the user interface that the dice has been rolled and it should be displayed in some way. So this is quite powerful. And it's also an example that what we actually want is, you should only need to change in as few places as possible when implementing a new change to your system. So if you would like to add a dice, you could imagine that this would be a quite common case, especially if we are to reuse this dice game in several different projects. Then you should only need to do this change in one place. And one place is of course a little bit relative, but in one operation is of course best. Just add something in one operation. The next step up is, well, we only need to change one class, as in this case. We needed to change a little bit in the play operation, add a new dice, and stuff like that. And the next step up is to, well, we just need to change stuff in the model, in this kind of like package or component. And the worst case is, oh, we need to change stuff a little bit here and a little bit there, and we need to retest everything, and well, it's a really hard change. So keeping the changes as local as possible is of course a goal here. And this has to do with a principle that we will talk about a little bit later, single responsibility principle, and you should keep your classes as focused as possible. And we also saw actually an example in our little circle class, if you remember, where we mixed the responsibility of the math and the user interface. And we could see that if anything changed, this class would be hard to reuse, and it would be prone to changes, of course, in user interface technology also. So, all right, you may have noticed that we have a slight problem here. Can you see the ugliness inside of this code? Yeah, exactly. You have some, well, you do the same thing here, and we do the same thing there, and we do the same thing there. So we have duplicated code in some way. And maybe you also noticed when I did this, I did copy-paste. I copied and I pasted. And this is a, well, often something that is creating this duplication of code. And Why is duplication of code bad? Well, maybe we change the root of all evil. Maybe we change the, I thought that was premature optimization, but maybe we change this interface. We just rename this. Then we would need to change it in 3 different places. And that's bad. Maybe we add some parameter. Oh, we should also send this information. Then we need to fix this in all places that we have this duplication of code. Maybe we have made a small error that we could not catch easily. So, yeah, if you copy code, you need to, well, maintain this copy in all places, and often it's maybe not as local as this, so you can see it in one screen, but it's spread out all over your application. So it can become a real problem. So if you spot code copying, or if you feel you do copy-paste, you should maybe refactor your code to handle this in some way instead of copying. In this way, in this case, what do you think we should do? Yeah, you could use an array of dices, this and loop over that array instead. That would be one solution, absolutely. Now we have the this as like attributes here and no array of stuff, so we won't be doing that in this case, but that would be a good idea, especially if we are to maybe add some parameter to the constructor telling how many dices there should be in the game. This could be a really good idea to have it more dynamic in this way also. Yes, another method. So we have duplication inside of one class. So one way of dealing with that is, of course, just to add a operation here. I will just call it roll dice. And we send a parameter. And we just copy this. So we basically do this instead. Roll MD1 and all of this goes away. So, as you saw, we got a lot less lines of code. The display operation became much simpler to actually understand what it does. It rolls the first dice, the second dice, and the third dice. It gets the values from each dice and sums them up and compares it to 9. And you don't need to actually understand this method if you don't want to, but if you would like to, you can of course delve into it also. So we actually increased the quality of the source code, made it easier to change, easier to maintain, but we did not change the functionality of the program at all. And this is basically what is the definition of a refactoring. We improve the source code or the design of the source code, but we do not change the actual functionality. So we should keep the same functionality as before. So for the end users, they don't benefit from this effort at all, actually. So this means it can be hard to motivate refactorings, especially to management that, well, how does this benefit the end product? Well, somewhere in the future it will be easier to change and we will hopefully have less bugs. So in many cases you don't really get the resources to do these kinds of at least large refactorings, but you should really try to get them in there anyway because they can add value to your product in the long run. So the next thing we could notice is we did these two types of consoles, the Swedish console, and we had one console from the beginning. And if I just switch these files, do you see something? They look very, very similar. This code is exactly the same. And I think it's only that character down there, and we had some public-private stuff here also. And we have kind of like the same operations here, but of course it's Swedish vs English. And I think this display dice is actually also the exact same. Kind of like does not keep the scroll. Okay. Yeah, so we have this repetition of code in two different classes. What should we do then? We can't really break the code out and put it in inside either the Swedish console or the console classes. And any suggestions? Yeah, of course you could just separate the languages out in a file. I think that is probably the best idea, especially if you are to have multiple languages. You could, however, argue that some languages require quite radically different user interfaces. German, for example, is kind of like 1.5 times longer. So if you have a lot of text in your user interface, you often need to switch the layout, because if you do a German translation, it won't fit, likely. We have an answer here. We can make an abstract class instead. Exactly. We could take the stuff that is the same from console and from SWE console and put it in some kind of base class instead. So if you have code duplication between classes, you could consider joining them by taking this similarity and put it in a common base class instead. And often this base class will be abstract, so you cannot really create any instances of it. So I think we should try to do that, just to see how it looks. Okay. Package view, public abstract class, base console. And let's put this get input here instead. So great. I think this one can also be put in the base console class. Possibly. Oh. All right, so we added an abstract class that we could put the common operations in. So, and these were just exact copies, actually, so that was not really problematic. So this has changed our design a little bit, but we got rid of this code duplication. So if we would like to change something here, we don't need to remember to, okay, I found the bug inside this class, and I also need to remember that we have this console that has the same operation in it that we also need to change. So I think that is it for refactoring this small game for now. We should maybe now take a step back and look at the class diagram that shows the design. So let's start in the model package, and I think we will find I think almost all types of stuff we need for class diagrams actually in this game, so this should showcase most of it. Model package first. So inside of this package we can take a look at the implementation. We have three classes: dice, dice game, and dice rolled observer. And that is not even a class, it's a interface. Let's start with the classes. Dice, dice game, and if you remember, they are connected by three different attributes in the dice game class. So these are displayed as associations in the design model. So if you have an attribute of another type, you have an association. And the role name here is D1, D2, and D3. I won't be printing those because it will just become messy. Then we have the interface. A really long name, iDice rolled observer. Seems like the smartboard has not gotten its cup of coffee either. Was it dice rolled observer? So let's make it a little bit shorter. I think this is actually a good practice if you can squeeze the name of the pattern in somewhere. So we named this one observer because, okay, we can trigger the developers to investigate the observer pattern or find the observer pattern in their minds if they have studied it before, and they should kind of like get a feel for how the system works and what this is for. And good naming is, of course, important. I think dice rolled observer is quite a good name because it's about dice being rolled. And well, if I see this class and I have something to do with dice being rolled, I would probably investigate it. So, okay. Do we have any relationships from this interface to any other type in the system? Let's check the source code and take a look at this. We don't inherit from anything. Well, it's an interface, so it can't inherit. We have no attributes. Well, it's an interface, it cannot have attributes. But we can have operation signatures. So, but we have no arguments of any special kind of type here. We don't return any special kind of type. So we actually have no dependencies from this interface. This also means that the only valid actually relationship an interface can have is the dependency relationship, because you cannot add any data to an interface, so you cannot have associations. And well, you can't inherit because it contains no code, so it cannot inherit anything, and it cannot fulfill another interface either. So the only valid dependency or relationship from an interface to something else is the dependency. And this comes from having return types or having arguments to these operations of some type. So if we, for example, sent the dice object, it would say dice, a dice, or something like that here. Then we would have a dependency to the dice from the interface. But we don't have any for this one. The next step is to check maybe, does the dice know about this interface? No, it does not. Does the dice game know about this interface? Yes, it does. It has this template class array list filled with dice rolled observer objects, and it's called subscribers. And this is an attribute, which means we should have an association. So let's add it. And just as I said when we started, should the program class be included? You could ask yourself, should we exactly say in the design that, well, it should be an array list. Maybe we should. Maybe we need to guide the developers that, oh, you will get a performance problem if you use some other type of collection here. So it should really be an array list. Or you could simply leave that up to the developer, the implementer, that, okay, we have this association, it should contain many. I can select whatever collection or whatever implementation of that I want to. It does not matter. And the role name was subscribers. So I think this is a good level. You can use kind of like this notation to say that, well, it should be an array list. So you can add stuff to your associations also. But, well, as you see, it adds clutter. And in this case, at least, it's not really that important what exact type of collection we use. So, well, at least that's one way of doing it. You can also use association classes, and if you are really, really into it, you should have an association to the array list class, and this class is a template class that you parameterize with iDice rolled observer class. So it could become really a little bit messy. And for these built-in types, I don't think it's actually worth it. So I think we are done for the model. Let's move it there for now. So let's take the controller. It's a quite small package, just one class. The player class. However, this class implements the interface, so we could take a look at that. We have an attribute here also, the view, so this needs to be added. And we have an argument here in the play game operation. So we have quite a few connections from this player class to other parts of the system. We should make it a little bit bigger. So maybe something like that. So we had this player class that fulfills the interface iDice rolled observer, so that we could add the player object that we created as a listener to listen to the dice that's been rolled. And this we display by adding the realization relationship. So it's a dashed line, and it's an arrow that is closed. And basically, you don't want to make a mistake by having an open-ended arrow, because then it would look like a dependency. And this would change stuff quite a lot in the diagram, so don't make that mistake. That is kind of like one of two mistakes you can make. You can often separate, if you make a mistake between association and dependency, you can often see that, well, actually it is an association because you have added multiplicity and a role name, so that mistake is less severe, so to speak. But if you make a mistake of having an open arrow here, it becomes a dependency, and, well, it becomes harder to actually understand what is meant here, because it means a completely different thing. So that was one thing. I think maybe we should just start with the view directly, because we had some stuff in the view also. We'll just hope we can get it to fit. And in the view we had, or in the player we had this attribute called mView, and it was to an interface iView, so let's just add that one to start with at least. mView. So let's take a look at the view package, and there we have quite a few things, I think. So maybe we should move things up a little bit. We have the base console, we have the console, we have the iView, and we have the SWE console. So we have 4 classes here. So let's start with the interface. Any strange return types? No. Any strange arguments? No. So no relationships from the iView to anything else. Then we have the base console. It's an abstract class. No strange attributes, no strange return values, no strange objects created. So nothing in relationship to the design inside our application at least. Maybe we could add that, well, we're dependent on system.out if we want to show that, well, this is the, and we're dependent on system in also. So maybe this is something that we should note in our diagram if we want to. But I don't think we will do that now. We will kind of like draw the limit of the design to our application. So this diagram is to show how the internals of our application works. And this was the goal of the logical view, if you remember. If we are to display all other kind of like upper and lower layers here, we could do this in the development view and think of our kind of like application as one component that is dependent on other more basic services that exist, and in this case the console. But we won't do that now. So let's add the base console. I think I will remove this for now. And this gets a little bit tricky. As you maybe noticed, if we have an interface, we add something we call a stereotype to the class, and this stereotype is the interface stereotype. And it's inside those little strange, looks like larger than and smaller than characters. Actually, it's not. It's special characters, but, well, often you can't find them, so you use larger and smaller anyway. But for an abstract class, there is no stereotype. Instead, you write the class name in italics. And, well, I tried. It's maybe not that obvious. So I don't think it's really a good choice in the UML notation to do this. Actually, I would probably just add an abstract stereotype, but this does not really exist. But I think that everyone would understand it, and it would definitely make things clearer in a hand-drawn diagram. So watch out for that, and well, add something instead. I think is much better. So, but we had no relationships from there actually, but we have the two view types left, and they look quite similar. We have the SWE console, and it extends the base console, and it implements the iView. Otherwise, we have actually no special relationships here. And no special relationships here either. So let's just add these classes also. So we have SWE console, black, SWE-con, and con. Should probably rename that to English console maybe. Anyway, interface realization. We have seen it before. Dashed arrow. And then we have the extension of the base console class, and this is modeled as an inheritance. And this is something that we have seen also before actually in the domain model as generalization, specialization. So the Swedish console is a more special class, special type of base console, and the same for the ordinary console also. And here we have the second mistake you can do. You can, if you leave this open instead of closed, it kind of like looks like an association, and the meaning of the diagram becomes quite different. So these are the two major mistakes you can make. You can mistake the realization for dependency, and you can mistake the specialization, generalization arrow for an association. Making a mistake between these two, like, oh, I made a full arrow here instead. Well, often you can see it's an interface, and in many tools you cannot even make this a generalization. It will automatically become a realization instead. So that is often not a real problem, and vice versa. If you try to fulfill the interface of base console, well, if you have a tool, it will notice that this is not an interface. But in a hand-drawn diagram, well, the meaning is not really that different. And vice versa with association and dependency. Well, in one case you have the type as an attribute. In the other one you have it maybe only as a return type or as an argument, or you create objects inside of it. So the meaning is not radically different, at least. I could maybe just close this one. So it won't fit really. I think I made the controller too big. could try just to make it get a little bit smaller. Ooh, no. Maybe. This is, of course, always the problem in modeling. Finding a good layout and stuff like that. So, something like this. Actually, we don't have a dependency here. We just have associations. So maybe we should just add the program class then to actually show the dependencies. No, we don't have any dependencies here, none there, and none there, and none there. None there. And none there. So, well, yeah, here we have the dependency. I knew it. We had forgotten this attribute. Oh, this argument in the play game operations. So this should, of course, be added. So from the player, I should have drawn that one this way. We have the dependency. So we have everything. Great. This is a class diagram. And, well, this is basically the notation for class diagrams that you need to know. You need to know how to make packages. You need to know how to make classes. You need to know how to make interfaces and possibly abstract classes. And you need to know these 4 types of relationships that we can put between these elements. And we have the association. And basically, if you have an attribute inside a class that is of a certain type, you show this as an association. And the name, the variable name of the attribute in the class becomes the role name. And of course, vice versa. Now we have done kind of like reverse engineering of the implementation to take a look at the design. If you do the opposite, you do the design first, well, then you implement the association as an attribute with the variable name the same as the role name. And we have the dependency. And basically, this is if you have a relationship between 2 types, and it's not an association, it's not inheritance, and it's not interface fulfillment, well, then it's a dependency. That's the only one left. So everything goes into the dependency. And most often, it's about arguments in operations. You can send in a type into an object of a certain class using an argument in an operation. So you send in an argument, this object is used in some way, and it's not stored in an attribute, because then it would be an association. So the association kind of like overrides the dependency. If you already have an association to this type, well, you don't add the dependency also. Because I think the straight line is supposed to mean, well, it's a little bit stronger. So it should be visually a little bit stronger than the dashed line. So the difference there is the association is a stronger type of relationship, a stronger tie between these 2 types than the dependency. And the same thing about interface fulfillment and inheritance. Using inheritance, you have some code that is actually reused inside. In the interface, you only have the interface signature to worry about. So the idea there is to show this by having the full line vs the dashed line. So the full line is supposed to look a little bit more strong or more intimidating. So the other way to get the dependency is to have a return type of some other type. We only had void in this case, I think, mostly. And often you create an object and then you get the dependency anyway. But one way you can get dependencies inside of an operation is that you ask some other object for some object that is contained. We could imagine inside the player here that we could ask the dice game that is sent in, can I get the first dice? And I can use this dice to get the value and do something with it. Then we would get a dependency from the player to the dice, because we ask the argument to the play game operation, can I get the first dice and do something with it? Maybe send it to the view, then that would also get the dependency to the dice. So that is maybe something you need to look out for. And especially if you have a language where you don't specify the types of variables inside your methods, you need to kind of like be wary of what does this other type actually return. Get dice, well, it returns a dice value or a dice object, so then I need to add a dependency. Some languages are really clear because you need to declare your variable type, kind of like dice d1 equals dice game get dice 1 or something like that. So it becomes a little bit more clear in the code what is, or easier to see in the code what type is actually used here. So then you also get dependencies if you get objects from some other class that are used in some way. I think the inheritance is quite easy because many languages have special keywords for this, kind of like extends or semicolon or whatnot. And also they often have special notation for interfaces and for interface fulfillment. In Java we had this implements. So it should not be a problem. There is a fourth way to actually get the dependency. Could you imagine something? One way, we have arguments. We can create objects and return them maybe, and we can get return values. So those are three ways to get dependencies. There is a fourth way. There could be global variables. So you could have something that is globally available to everyone. Of course, this is a bad practice, but you could have that situation anyway. And also, maybe you add some static types, static operations inside some class that you use. Then you also get the dependency. This is actually almost the same as having a global type. It's kind of like open for everyone to use and access in an easy way. So if you have static operations or static variables or global variables and you use these, you also get dependencies. So remember that. Okay, one question. Do we need to add methods, attributes in class diagrams? Well, in many cases, no. I don't think so, especially not if well, the goal of this is to show the design and to focus on the relationships between the classes. And adding operations, well, it just adds another box here and another box under, so you get three kind of like boxes, and well, it just becomes really, really big, and then you can't see the arrows suddenly and stuff like that. So especially if doing hand-drawn diagrams, it's often more work than it's worth to add these. If it's really, really important, like telling the carpenters exactly where to put their nails, then maybe you should add it to the blueprint. But often it kind of like takes more away than it adds. If you have good tool support, this could be solved by, well, in one view, I just want to see this. I want to focus on this class, and then maybe I can see all the relationships that it has, and maybe I can see the attributes and the operations also. So being able to have a tool that we can use to zoom in on certain aspects could absolutely solve that issue with adding too much cluttering in one diagram. I think for the second workshop, I think it's not at all that important. It's much more important that you show how things are actually connected than to add every type of attribute and operation in every single class. Maybe you have some attributes or operations that you really want to show, then you can do that if it's really, really important. So you need to kind of like use your own judgment in when doing models and diagrams, and you need to think about, okay, what is this actually for? Is this for finding some way to restructure this to make it better? Well, then maybe operations as attributes are not that important. If we have some really important interface, for example, well, this interface is the central point of many things in our application, then maybe we need to specify this interface really, really well, and then maybe we need to add the operation signatures there, so that other programmers can actually see from the blueprint, okay, I'm about to fulfill this interface, it does not exist in the code base yet, but I should have these operations in it. So it depends on what you need your diagrams for, how detailed they should be. And often, well, maybe you don't make a detailed class diagram for a whole application. Rather, you focus on some area. Well, this area is problematic and hard, and when we do this type of change, it's cumbersome, and we need to change many things. Maybe we should make a class diagram over this part of the application to see how it looks, and maybe find some opportunities to restructure. Yes, we will take a look at interaction diagrams in the next lecture, actually. And basically, interaction diagrams show dynamic side, shows objects collaborating. Class diagrams show the static side of things, how classes are connected. So it's important to make this distinction that interaction diagrams is about executing scenarios, executing software. So there we have objects of types that are used. In the class diagram, we only have the types and how they are connected. So I think it's time for a break. And we will take the last stuff of layers and components after this break. So 15 minutes of a break.